morning, folks. Humble request from our side, if you can wear your headsets and give us a thumbs up, we're good to go. Awesome, thank you so much. All right, welcome everyone. Welcome to COP333, Scaling Open Source Observability Stack, featuring Warner Brothers Discovery. My name is Vikram Venkatraman. I'm a solutions architect here at AWS. I work with some of our strategic customers that operate AWS at large scale. Along with me, I have Abhikana, Product Manager, AWS, and Hans Robert, Director, Warner Brothers Discovery. Let's get to the point straight. Imagine it's the night of the season finale of your favorite OTT show, and you, along with millions of users, are waiting to watch this show, pressing this play button simultaneously, only to find out there is this annoying, revolving circle that just rotates and never stops. And on the other hand, the provider goes like, thinking like, what's wrong with my platform? Is it the authentication system? Is it the payment system? Or is it the both, right? Unfortunately, folks, that's the state of running systems at large scale. When you have hundreds or thousands of microservices running on a various compute platform, the challenge isn't about collecting metrics, logs, traces. It's all about making insights on top of these metrics, logs, traces. And that's exactly where we feel modern observability can help us. Rather than just being a mere monitoring tool, it can help you identify where the problem is, what was the root cause, and how you can fix it. And that's going to be the focus of today's session. In minutes' time, you'll find Hans here sharing the stage with us, who's going to talk about how Warner Brothers Discovery derived insights out of these metrics, logs, traces stored at large scale, and we're able to bring down the mean time to identify and remediate operational issues. As far as the agenda, folks, we'll start with observability evolution, where we try to understand the basic blocks of observability, which is metrics, logs, traces. And then we'll dive deep into some of our managed open source services that can help you store these signals in a reliable and a durable way. And then we'll hand it over to Hans to talk about Warner Brothers Discovery's journey, observability journey into AWS. And then we'll wrap up the session with best practices of operating these observability tools at scale. Sounds good to you all? Quick show of hands, how many of you here operate 50 plus monitoring dashboards in your environment? Keep your hands raised if you have 100 plus dashboards, 500, 1,000. Wow. Yeah, that's the challenge. When you have like too many dashboards, correlating the insights out of these dashboards isn't going to be that easy, right? We'll try to, hopefully we can learn something from this session, be able to apply some of those best practices in your environment. Now, I really wanted to emphasize on the importance of having a solid observability stack, folks. Look at these examples. E-commerce platform, healthcare providers, commercial banks, they all suffered a huge financial loss just because they were flying blind. They didn't have a good observability stack, and it took them hours for them to identify where the problem was and fix the issue, right? As our CTO says, everything fails all the time, but if you engineer your applications for those failures, meaning if you have the right KPIs in place, have the ability to correlate these telemetry signals, that's going to put you in a peaceful spot. That said, let's understand the fundamental blocks of observability, which is metrics, logs, traces. Logs in a simple term is nothing but how a human would record day-to-day stuff, right, in his diary. Like it has a timestamp in it, it has a detailed description of the event, that's pretty much it. Metrics, on the other hand, gives you the ability to look at an application's pulse. Is my application running fast? Is it slow? How many 4xx errors? How many 5xx errors, right? It's going to help you dive deep into a specific component within your application. And traces, it gives you the ability to capture your end user's request as it flows through the complex microservices architecture. Right from, let's say, the user orders something on an e-commerce website to getting that product delivered to him, right? It captures everything. But this talk is not going to be about collecting metrics, logs, and traces. No. It's about how you can reduce mean time to identify and resolve any operation issues, right? So we thought about it, looking from a lens of an on-call engineer, right? Any on-call engineers, SREs in-house? There you go. So from your perspective, right, like you wake up one early morning and find out like there are thousands of alerts waiting to be attended. And in order to get to the root cause of the problem, you may have to go through, like let's say 50,000 time series of metrics, 2 petabytes of logs. And remember, you're already racing against the time. when a 5-minute fix takes 5 hours for you to troubleshoot, we aren't talking about a monitoring crisis or a monitoring challenge. The challenge is with correlating all these telemetry signals, right? So we thought about it and we came up with this layered approach where the first layer is all about start with something, right? Like use the out-of-the-box monitoring. You get a page alert, you get a down alert, you get a 100% CPU utilization alert. So that's going to be your starting point. It's going to tell, okay, a particular application is impacted. And then dive deeper to the second layer, which is, get to the logs of that specific application and see like what's happening. Maybe you're getting a lot of 5xx errors, right? So let's dive deep into the logs and understand what could be the probable root cause of the 5xx. Then comes the third layer, right, where you enhance this information with trace information. Oftentimes, it's not that specific application that is the root cause, right? Like, let's say you get a down alert, it's not maybe related to that application, but it might be related to a dependent services, right? And that's exactly where trace can be handy. So the 5xx errors that I'm talking about could be a result of a backend database failing out. And trace can help you identify that information because it's going to give you the time spent by each of these requests in each of the microservices that forms your complex microservices architecture. And finally comes the critical piece, which is the correlating piece. And this is exactly where you have to inject some kind of metadata. So that way, when you troubleshoot the issues, you can correlate all the information from metric log traces, and you can pinpoint what could be the probable root cause. And this is also an area where you could use AI, because AI out of the box can pull all the information from your telemetry signals and also can lead you to a root cause of what you might be facing. So this is what we thought about, and with that, I'm going to hand it over to Abhikana to talk about some of our managed open source services that can help you store these signals reliably. Over to you, Abhi.
Thank you so much, Vikram. So here at AWS, we've built together a variety of different open source observability tools. From collection, we support open telemetry as well as managed collectors for Prometheus metrics. From an ingestion, storage, and analysis perspective, we've got the Amazon Managed Service for Prometheus metrics, and the OpenSearch service for logs and traces. And a variety of visualization capabilities stretching across managed Grafana as well as OpenSearch dashboards to stitch it all together. Many customers have told us that they prefer open source. So we often ask why. And the things that resonate are open standard support, allowing you to have a no vendor lock-in strategy, getting the best that the community has to offer, being able to get lots of transparency and control over what you're running, and then of course being able to tweak at your will to get the cost efficiencies you need in your observability platform. But unfortunately, it's not as easy as just a Helm install, put it into your production stack, and be ready and off to the races. Things don't scale, they're not reliable, they tend to get overloaded when you have too many teams using them at the same time. All of this creates friction. You have to deal with resource management and capacity planning issues, high availability problems, tenancy controls and isolation, just dealing with the sheer number of servers you have to go manage, patch them, upgrade them. And then of course you have to monitor all of these systems to make sure that they stay up and running so that your teams can use them to monitor their actual applications. All of this adds operational overhead that gets in your way of leveraging these open source technologies to help you solve these problems. Here at AWS, we've looked at how do we provide managed open source solutions. Firstly, we're looking at how do we make them end-to-end so that you're not sitting there cobbling together all of the pieces. How do we bake in correlation so you can correlate across metrics, logs, and traces directly through the product experiences? How do we make sure that you have the visibility into the cost elements, that you have cost controls that you can use to go tweak your cost efficiency? And how do we provide this at the AWS guarantee for security, at the scale you need to support your enterprise workloads, seamlessly integrated with all the other AWS technologies such as IAM, CloudFormation, CloudTrail, and of course, all of the improvements we make, how do we make sure we're giving them back to the community so that those communities prosper and get the same the same benefits with regards to scaling and availability? Just in case you're not familiar, here's a quick overview of the Amazon Managed Service for Prometheus. It's a highly available, secure, and managed metric offering. It's serverless, fully Prometheus compatible, supports the same open source Prometheus data model and query language. It's all pay as you go, and of course supports any environment and any scale. Last year, we launched support for 1 billion active time series per workspace, and you can have as many workspaces as you'd like, allowing you to have billions of metrics stored and analyzed in one system. course, we also have Amazon Managed Grafana, which is our managed offering for the open source Grafana project that allows you to pull from a variety of different data sources and build these beautiful dashboards, creating that single pane of glass feel. And then finally, we have the Open Search service, which gives you a real-time search and analytics capability across your logs and trace data. It's fully managed, it's secure to that AWS standard, supports log analytics and observability use cases built in with those experiences, and then of course is deeply integrated into the AWS ecosystem. Putting it all together, you now have the ability to use OpenTelemetry to collect logs, metrics, and traces, store your metrics in Amazon Managed Service for Prometheus, logs and traces in OpenSearch, and then of course visualize it across Grafana and OpenSearch dashboards. Regardless of where in the AWS ecosystem you're collecting this data from, you now have an ability to source that data, collect it, tweak it, ingest it properly, analyze it in these systems, and of course pull it all together in a visualization layer of choice, allowing you to create those single pane of glass views. Our customers oftentimes deploy this in two different modes. One is a centralized mode, where across all of their regions and accounts, they're pulling all the data into one central location, into these central open source observability stacks that allows them to get a cohesive view of all of the different places they're running their applications across their AWS footprint in one single location. Other customers have developed a more geolocal strategy, where they've got a single stack per region, where they centralize across all the accounts in that region, and then they use a common visualization layer to stitch it all back together at the end. And with that, I'll hand it off to Hans to talk about the Warner Bros. Discovery story.
Thank you, Abby. So we just heard about those amazing tools and products that AWS has made available for us together. They've never been powerful as ever before, and yet tools have limits in terms of how much they scale. For really surviving at the enterprise level, you need scaling strategies, and that's what I want to talk about today. Good morning, everyone. I'm Hans Robert. I'm a director of observability at Warner Bros. Discovery. Warner Bros. Discovery is fundamentally a company of storytellers. We connect audiences with powerful stories and narratives, and we're the home of iconic brands like CNN, Food Network, HBO, TNT, amongst some others. We operate a very complex ecosystem that is very crystallized here in our streaming world, comprised of HBO Max and Discovery Plus. We support 128 plus million subscribers across 100 plus markets, all of that on one multi-tenant platform. So the volume of logs and metrics that we collect on a daily basis is pretty staggering. And so for us, collecting all those logs, metrics, and traces is more than just something that we have to do. It's really an operational imperative and a retention must-have. Today, I'm going to share some of the learnings and some of the strategies that we've used to scale the observability platform that Abby was talking about to actually meet that enterprise challenge and scale to some of those numbers. So when we got started a few years ago, right after the merger of Discovery and Warner Bros., we were facing the classic technology merger challenges of having multiple different observability solutions. Different teams were using different things and tools, looking at different data, and that made very slow troubleshooting and identifying of issues. We also suffered from lack of data standardization. Inconsistent data formats and taxonomy made correlating insights across teams a complicated issue. And finally, and most critically for what we're talking about today, this hurt our scale challenges, making every event traffic or just keeping up with subscriber growth a bit of a headache that we needed to solve. As you can imagine, this legacy state was inefficient, unsustainable. It didn't work well with our desire to reduce MTTR and be able to resolve the incidents as quickly as we wanted to. So we built a completely new platform based on those open source technologies that Abby was talking about. Before I talk about the strategies, though, I want to talk a little bit about the open source and why open source. And Abby mentioned a few of those reasons here, but I want to just double down on some of them. First, we wanted to avoid what we call the one-way door, the kind of things that we make a decision or a choice that actually is very hard to revert or evolve over time when your needs arise. Or being able to really sort of be pegged to one specific proprietary vendor technology or strategy. Second, we wanted to build an opinionated platform where we actually build a lot of the guardrails and golden pathways straight within the platform. Things like the guardrails are there to prevent user mistakes, errors, data spikes, anything that would actually make the platform in trouble. And the golden pathways are there to really sort of help teams, engineers to onboard onto the platform and leverage as best as they can the observability platform. And then finally, and maybe most critically from a cost perspective, we wanted to have full control over our data and the pipeline. So both from a data pipeline and data retention and storage, we wanted to make sure that we knew exactly how and when we collected the data and then where we store that. Let's talk about some of those strategies that allowed us to scale our platform to where we have today. And I'll talk about three different things that matter to us a fair amount. Data organizing, optimizing our system through sharding, and then finally cost metering and how we manage our cost. My goal today, if I can, is to give you some strategies that you can apply to your industry, irrespective of whichever it is. This is not specific to video streaming, and that you can apply and hopefully use it the exact same way that we've managed to scale up. So let's just start with data organizing and how we've tamed the chaotic volume of information by organizing it. So I'll touch on a couple of things, but maybe, first of all, the industry cliche is data is the new oil. But frankly, in my cautionary views, data at scale is chaos by default unless we organize it. So today we focus on two pillars of how we organize the data. First, establishing an operational metadata, OMD for short, to tag and track our data flows. And secondly, implementing a unified event schema across both logs and traces. So operational metadata, OMD for short. So this is not an observability specific strategy, but as you'll see later, it's foundational to a number of things that we've done later to both shard and scale. And so, I want to make sure that you get a good grasp of that. So we wanted to establish a functional hierarchy for WBD streaming ecosystem for all of the applications and infrastructure that we have there. So you can see on the screen we have this kind of simple three-tiered hierarchy of systems with business services at the top, like video playback in this case, and that represents a kind of high-level business capability. Below that we have the OMD service, like markers, and that is really like a logical feature within capability. And then the last one, the OMD component, is really sort of the final microservice that implements a specific feature within that capability. And in case you're wondering, markers is how we track what and how you've been watching your streaming choices, so that if you pause and want to resume later, we know where you were. And so that's the marker. So establishing that, we need to really sort of distribute the authorship and the collection of that data. And we sort that by distributing it directly to having the engineers, pressing the wrong button, putting all that information into a standard file format in GitHub alongside their code. Easy, and we implemented some automated checks to enforce the data quality. And then on top of that, we're essentially now scraping all that data and collecting it and storing that in Amazon Aurora, on top of which we built a Grafana dashboard called Service Catalog that gives us the entire topology of our system. So all of this is providing a single source of truth that is the operational and functional map of our entire platform. And by that I mean the application platform, the streaming platform. But as you'll see, this has great relevance for observability later. So now we have our operational metadata established. The second critical goal was really to map all of our observability data, whether that's logs, traces, metrics, to this functional hierarchy. So here there's an example of a log on which we've essentially applied that OMD business service and component, video playback, markers, and collector, so that that data is now tagged and organized. And then to scale, this tagging had to be automated. So we engineered a solution to enforce the standardization at the collector level. So in our Kubernetes cluster, we're running Fluentd to collect the logs. And alongside Fluentd, we have an add-in that essentially tags automatically the incoming data from Fluentd with the information collected at the node level that contains the business service, and components. And now that we've tagged all of this information directly onto the message that we send to the observability account, we know exactly where the data comes from and what it belongs to and what it's relevant for. And I'm not showing you here on the screen, but we've done something very similar for metrics and traces so that all of our metrics have the OMD business service and component, and similarly traces have the same thing. So this automation guarantees that every piece of data that's destined to our observability account is correctly tagged regardless of volume. And that's important for scale. And it's also pretty structural and fundamental to some of the sharding strategy and so the cost metering strategies that I'll talk about in a moment. But before I get there, I want to talk about the other aspect of organizing data. So that's typically for event data being logs or traces. Without establishing a strong event schema or standard, every service and component, i.e. every team or developer within your company, operates independently. And that typically leads to like schema drift, where even a simple entity like a client identifier can be represented in multiple different ways. Client underscore ID, client dash ID, CLID, etc. This is not just a semantic issue, it's an operational blocker. You cannot join data with different identifiers easily and efficiently. In addition, it also really impacts indexing. I already mentioned the cross-service correlation, but also massively increased the query complexity and the cost of storing that data. So solving that schema proliferation was important to achieving our scaling observability platform. So we've introduced the organization-wide logging schema. It's a bit of a mouthful, but so we've shortened that to OWLs. As is built upon a mandatory core log schema. So every log, no matter what, have non-negotiable fields like timestamp or severity here, or other things like message, or the OMD fields that I just talked about a minute ago. On top of that, we can have business service aligned schema that define things that are more relevant to each of those business services. Like for the payment log schema, you want to add the payment method type or the payment reference. And then for video playback, video ID or stream ID, etc. Core log schemas and business schemas are then merged into a specific business-oriented schema that it gets injected into the OpenSearch index. We now have a very dedicated schema, but with common fields that are originating from the core schema. So this enforced mapping ensures that if any event attempts to ingest something that's not defined part of the schema, field can be rejected, or can reject the message, or just the irrelevant fields, or store that in S3 for further review. And then we can send a notification to the author of those logs and basically tell them to fix it, try again, do better. One of the things that has changed is also part of that culture and the conversation, knowing that some of those events might be rejected if the log just goes outside the boundaries, have really made people think a little bit more about what and when to log things, and potentially having a much more intentional way of sending information to the observability platform rather than just like filling a data swamp with stuff. So combining OMD, the operational metadata, and our OWL schema, we've achieved a few critical outcomes. The accelerated MTTR really comes from the data quality, but also from some of the data standardization and the ability to connect different services and microservices together. Intentional consumption, I just mentioned that a minute ago. People really think twice now about what to log and what metrics to log rather than just filling up to infinity number of observability telemetry that they can think of. And then finally, it's a really good foundation for scale, and you'll see how we're going to be using the operational metadata itself to actually build on for sharding, but also some of the cost metering. All right, so that gets us to sharding. Abby mentioned some of those strategies earlier. We've adopted really for the geolocation approach, which we'll get to in a minute, but also talk about some of the logical partitioning that we needed to do in order to get to a point where nothing is too massive. And I'll talk about the need to abstracting shards because of the problems that shards are creating. All right, so Geosharding. For context, to serve our 100 plus markets in our 9 regions globally, our business applications are distributed across those kind of like 9 regions. And most of our components and compute are running in EKS and with a supporting cast of services like database and storage that are all monitored by CloudWatch. So looking at logs first, we have FluentD collecting logs directly from the pods in EKS, and then forwarding that data to a regional OpenSearch, i.e. in the same region that the data originated from. And we replicate that across like every region that we have around the world. Metrics have a very similar path. We use the Grafana agent in this case to scrape EKS metrics directly from each pod and then send that to an AMP workspace that lives in that same region. And then finally, to bridge the gap with Amazon CloudWatch, we've leveraged YACE, yet another CloudWatch exporter that extract the data from CloudWatch and forward it to the same AMP in that same region so they can now do correlation between infrastructure and application, which gives us a step forward the single pane of glass. Let's move to logical sharding. While Geosharding handles the physical location and provides already some form of sharding, we also need a strategy to organize logically so that nothing within that region can become too massive. What if, for instance, you need 1.1 billion metrics in Prometheus? It now goes to 1 billion, so you need more than one. So for metrics, Grafana agent reads the OMD label that's now very familiar to all of you here, and uses that to make routing decision. So rather than send everything to the same huge backend, we sort of like shard that, leveraging the business service or component as needed in order to get the optimum distribution. And then we apply the exact same logic on logs and traces, in this case leveraging FluentD, that forward things to Firehose and eventually to the relevant index in OpenSearch or instance, where it's essentially automatically indexed within the relevant logical index for that business service or component. So with this strategy, we're really sort of like preventing not only things to become too large, but also to have one service or one component or one business service to create a traffic spike that would noisy neighbor or impact the ingestion performance of another service that happens to live on the same in the same ecosystem. And so for risky components or things that are very spiky in nature, we tend to isolate them onto their own dedicated shop, so they can only impact themselves. So I talked a little bit about shard limitations. The main issue with shards and sort of like the partitioning that we explored here is that you can no longer just have Grafana just doing one query. It really has to know intimately the topology of your system in the back end and really sort of like query the data from where it belongs. And then, knowing which AMP workspace actually contains your data. Is that the one in US East 1, in Europe? Is that the one for video service? This can lead to something that's actually quite complex and complicated to manage. We have the same friction with logging and tracing, where the OpenSearch dashboard would also need to know where that transaction or where that log was ingested from in order to actually capture that specific message and really address the exact OpenSearch that contains that message. So as you can imagine, this is not really a practical way to implementing that. It gets pretty tedious pretty quickly and slows down that MTTR that Vikram was talking about that we're really going after. So we introduced a couple of abstraction in this case. So starting with metrics at the top, we introduced proxy, which is also hard to say for some reason. For those who are not familiar with proxy, it is a open source aggregating proxy that sits in front of your data, but looks from a Grafana perspective exactly like a Prometheus. So proxy acts as one giant AMP workspace, and then under the hood just like shards the query or distribute the query across all of the different workspaces that it knows about, brings back all the data series, we put them back together, and then feed that back to Grafana. So with proxy, we effectively have a complete abstraction that Grafana doesn't need to know about, like how many workspaces there is behind the scene. Is it 1? Is it 70? And then for logs and traces, we have leveraged the OpenSearch's native cross-cluster search capability. It does pretty much the same thing as what proxy is doing. It basically distributes that request to the difference of underlying OpenSearch workspaces or clusters that you have behind the scene, and essentially reaggregate that together before giving it back to the OpenSearch dashboard. So not only we've made it sort of like easy and efficient for people to write queries or dashboard or build alerts or any kind of visualization on top of the data, importantly, we've also completely disconnected the life cycle of the backend, i.e. the need for restructuring and re-architecting how many shards, where they live, from the consumption on the front end. And we're able to change all of that without having to impact the consumer. So a dashboard that was written in this architecture with 3 AMP workspaces would work tomorrow with 2 AMP workspaces or 3 or 5 AMP workspaces as we scale, because it's still talking to the exact same proxy instance. And then same thing for the OpenSearch dashboard. It only knows about the one cross-cluster search instance that will then do the federation. So to recap, really this combination of geosharding, logical partitioning, and the abstraction that we've built really has given us like a very flexible and scalable architecture. We effectively future-proof the platform. If the business decides to launch in a new region tomorrow, or if we expect a specific service to have like a 10x in traffic, or if there's new capabilities that would generate a ton of logs and metrics, we can do that pretty simply by just adding a new shard or launching a new cluster, and without disrupting any of the SREs, engineers that are leveraging Grafana and OpenSearch dashboard to query that data. All right, final strategy, this time around cost metering. If you recognize this guy on the screen, you know that what this section is about. And if you don't recognize him, he's Roy Logan from Succession, a show I would highly recommend for you to watch on HBO. But if you still don't know who that is, you can think of the CFO, the CEO of your company. those people don't care about, I don't know, high cardinality or index fragmentation. They care about the bottom line. And to survive at scale, we had to implement some kind of financial showback or chargeback to understand where the costs are coming from and to make sure that observability doesn't become the most expensive line item on the AWS bill. So there's a specific challenge within AWS to do cost attribution in a shared environment. So imagine we have those two services, payment and video playback, and they both send logs and traces to one OpenSearch service backend. Similarly, they're producing metrics, most likely at a very different cardinality. They might have completely different time series numbers, and they all end up in that same sort of AMP workspace or AMP instance. Today, the native strategy within AWS is to tag the instance, which means that if you navigate to the Cost Explorer, you're going to know the total amount that we spend for OpenSearch or for Prometheus, but not the detail of, who's actually generating that cost. Is that payment? Is that video playback? How do we sort that out? So to close this attribution gap, we've engineered a bespoke cost metering framework that essentially triangulates three different types of data. One, the cost. Can't live without that. So we extract that from AWS and we store that into an analytics platform. The second is getting the usage of both OpenSearch services and AMP by collecting specific volume metrics, for instance, log gigabytes, number of traces, number of time series in AMP, and then we generate essentially a new time series that we store in Prometheus. And then finally, we allow for teams to really enter allocation rules, like how do you want to partition and mathematically divide that amount of money based on the rules and based on the cost that we have there. So you got the three sets of data. The magic of the reconciliation happens in the middle here in Lambda. This runs on a trigger and essentially merge all these things by mathematically dividing the cost that we've collected for both of those instances and basically saying, you spent more, you pay more, etc. And then we create yet another time series that in this case we store in Amazon Time Stream. And then finally, we've built a dashboard, because what would you do without a dashboard? In this case, in Grafana, and then we have built a dedicated dashboard for each of those business services that now know very well the specific costs associated with their observability platform. Now, on top of that transparency and the visualization, we've also built an accountability framework. It's not just sufficient to have that available. There also need to be a little bit of accountability, going behind the scene there. And that has also kind of changed the culture, a fair amount. We've sort of moved from a conversation about, why is the AWS bill so high, to more of a, how can my team contribute to sort of like really managing the cost efficiently and appropriately. All right, so now that we have those three strategies implemented, we've successfully built a platform for the future of streaming. And by implementing the strategies that we shared today, we established three powerful pillars. Global observability solution that's scalable, leveraging managed services like Amazon Prometheus and OpenSearch. We transformed our data into a strategic asset by standardizing operational metadata and then the schemas. We've ensured that every metrics, logs, and traces are immediately valuable, searchable, and trusted by the engineers that rely on them. And then finally, we've unlocked scalability. Through intelligent sharding and our cost metering framework, we've really sort of have an infrastructure that scales alongside our subscriber growth. And we can expand to new region or handle spike traffic if we need to. If your organization is facing similar growth challenging or issues, I highly encourage you to look at those strategies. They've been game changers for us. Thanks. And before we conclude the session, I want to hand it back to Vikram, who's going to talk to you a little bit more about how to operationalize a scalable observability platform.
All right, we're going to wrap it up with sharing some of the best practices of operating observability tools at scale. The way I've divided this is into two sections. We'll talk about the best practices of collecting the telemetry signals, namely metrics, logs, traces, using your collector of your choice, OpenTelemetry for metrics, traces, and then for logs, maybe Fluentbit. You also have the OpenSearch ingestion pipelines. So that's going to be the first lesson or the first best practices that we're going to talk about. And then the second one is about how can we ingest these telemetry signals into Amazon managed open source services in a reliable and durable way. It's no-brainer. Start with sampling and batching. Many of you might be doing this already. Anyone who here does like sampling and batching as part of their collectors? No one? Okay, so when I say sampling, we only keep the percentage of data that we care about. Goes long way when you're dealing with huge volumes of traces. And when batching, we kind of group the signals before we ingest them into the backend, right? So by following both sampling and ingesting, you're making sure that you're not overwhelming the backend as well as reducing the overall network overhead, right? Like as a result of ingesting these telemetry signals. And when it comes to metrics, right, these are high cardinality information. So at any point, if you think any of these labels might not add a huge ton of value to you, I would request you to drop those unnecessary labels, right? Especially you have this action config within your OpenTelemetry collector or Prometheus collector. It's very straightforward. You just have to specify the label and simply drop it. What it's going to do, it's going to keep your time series metrics, time series database less, as well as it's going to improve the network traffic from your collector to the backend telemetry, backend open source managed services also not going to be overwhelmed. And good for us, many of our collectors has these best practices out of the box. Like for example, compressing, right? So there is this compress, like out of the box, OpenTelemetry supports gzip compression. So you could use that. So you kind of compress these telemetry signals before you send them out. And you can also enhance your telemetry data. By enhancing, I mean, there are like, anyone here uses K8 as attribute processors within their OpenTelemetry or Prometheus? Not really? Okay, one person, perfect. Yeah, you could add necessary metadata into your telemetry signals. For example, you could add the deployment config, you can add the pod name, you can add the namespace name. It's going to further enrich your telemetry signals that you're collecting. And when it comes to the logs, you definitely have to monitor and optimize your buffer usage. You have to configure dead letter queue so that if some of your requests fail, you don't drop them, but instead you move them onto the dead letter queue and try revisiting it or troubleshoot on what happened. And finally, the most important piece is you have to definitely monitor your monitoring tool. You have to set up some kind of an auto-scaling strategy. You have to, like OpenTelemetry out of the box gives you a lot of metrics that you'll have to keep an eye for, and also make sure that you have sufficient resources configured to your collector and have some kind of a auto-scaling strategy. Lesson 2 is about how we can better ingest these telemetry signals into Amazon managed Prometheus and Amazon OpenSearch service. Again, these are out-of-the-box features that's available. Whenever it comes to complex queries, it is highly recommended to use recording rules. That way you don't have a complex query or overwhelm your Prometheus database. Instead, all these recording rules will be computed at regular intervals and will be transformed as separate time series. Amazon Managed Prometheus also announced label-based active time series in a multi-tenant environment where you have non-mission critical mission-critical applications running on the same clusters. You can specify a cap on how much of an active time series that you would be willing to use for a specific application. So you can scope down them by labels, non-mission critical time series. I only need like 20,000 time series. For the mission critical, maybe I need like 1 million time series. So you can scope them based on the labels. And you definitely can implement query controls and query logging. This gives you the ability to specify how many samples should I traverse through to make sure this query runs. Right? You wouldn't want to run like your query against like a huge number of samples, but you can specify the number of samples that you could use. And when it comes to Amazon OpenSearch, the first and foremost thing that you have to do is you have to definitely calculate the storage requirements. You'll have to account for index overhead. You have to account for replicas, your data flows, and make sure you select the right instance type and the storage requirements. And you absolutely must have a sharding strategy. A general rule of thumb, we recommend to have like less than 25 shards per gig of your heap space. You have to control the ingest flow and buffering. And again, we have the OpenSearch ingestion pipeline that can take care of that. So would recommend using OpenSearch ingestion pipeline in tandem with your Amazon OpenSearch service. That way you don't, again, you kind of control the log flow. And finally, you have to optimize the bulk request and compression. Use the bulk request API so that you can batch your log flow and finally compress them and send it to the backend, which is your Amazon OpenSearch service. That said, I also wanted to highlight some of our recent announcements we made on the AWS managed open source services this year. I'm going to let the slide sink in here. If any of you have any questions on these features, we'll be more than happy to answer your questions in the hallway. But we kind of talked about some of those important announcements as part of our best practices slide. That said, I would like to thank you all for stopping by, attending our session. Yeah, thank you so much, folks.